Hello, my students for Edexcel board. Today we have Unit 2 of AS Advanced Subsidiary, October 2023. Okay, this is the cover page of the paper. As you can see, this is the date, and this is the title of the unit, which includes energetics, group chemistry, halogenoalkanes from the organic chemistry, and alcohols. As you know, the total marks for this paper is around 80, or it's 80, and it is converted to 120 degrees or 120 marks. The first part is the multiple choice questions. And for the first question, the mean titer for the CF bond enthalpy is positive 485 kilojoule per mole, which a process has an enthalpy change of 1940. As you can see, if you multiply this by 4, you will get this number. And if you are looking to the first part, it is the composition or the formation of CH4. Okay, so the first one is wrong. Okay, and the second one is the formation of the CF4 in a gaseous state. For part C, it's CF4, which is converted to C in the gaseous state and 4 atoms in the gaseous state. For part D, we have a molecule which is also wrong, and this one is formation is also wrong, so the correct answer is C. Now, for next part, which expression gives the standard enthalpy change in kilojoule per mole for the reaction shown? The reaction is the thermal decomposition of barium carbonate to barium oxide and carbon dioxide. And he gave you the delta H formation of all these components, the reactants and the products. The delta H formation of the reactant or the barium carbonate is negative 1216 kilojoule. For barium oxide, for carbon dioxide, those are the values. Now, to apply this, you can apply the Hess's law diagram, where it is like that. Okay, you will see to form barium carbonate, it is formed from the barium in a solid state and carbon in a solid state, and also it is 3/2 O2 elements in the gaseous state. And those also, they will form barium oxide and carbon dioxide. As you can see, this is the delta H of formation of barium carbonate, this arrow, and this is the delta H of formation of barium oxide. This one represents the delta H of formation of CO2, of carbon dioxide. And all these, they are 1 mole, so there is no need to multiply with a factor. Only just you shall apply the values as they are in the question. So it is delta H of formation of the products minus the delta H of formation of the reactants. So you will see that he inverts this sign of the first one. So you will see it is products minus reactants when the reactants changed or the reactants charge was changed. So A is the correct answer. But all the others, they are incorrect. Now, for next question, the standard enthalpy change of combustion for a series of alkanes are shown. As you can see there, he gave you the table where it includes the delta H of combustion of the following substances. We can describe, or what is given is the delta H of combustion of different alkanes. As you can see, ethane, propane, butane, and pentane. Another alkane has an enthalpy change of combustion of around negative 6,125. So you will see that he is asking you the most likely formula for this alkane. Okay, if you calculated the difference between the standard enthalpy change of combustion of the different alkanes in the table, you will find it's around, for example, between the first and the second, it is around how much? You will see 2,219 minus 1,560. You will find it's around 659. Between the second and the third, it's 2,877 minus 2,219. So this is also, it's around 658. And you will see the difference between the, for pentane, it's a 3,509 minus 2,877. So it's around. So now, if the value is negative 6,125, so you will see the difference between the last one, 6,125 minus 3,509. So this equals 2,000. The difference between this and this is 2,616. Now, if you divide this over 658, or the average of these, okay, you will find it will be 3,900 or 3.97. So 3.97. Now, this means that you shall add more 4 carbons for this. You will reach C9H20. So if you add 4 more carbons, this will give you C9H20 according to the application of the general formula of the alkane, which is CnH2n plus 2. Okay. The next one, okay, can select rotate to, sorry, annotate, so it's better. Okay, next one. Which row in the table shows the forces between the molecules in the liquid state? Okay, he gave you different molecules: boron trifluoride, methane, ammonia, and hydrogen sulfide. Do we have London force in PF3? You can see for PF3 it's a trigonal planar shape and it is non-polar, so it shall include the London forces because it's non-polar, and all molecules they have London force, so this one is wrong one. So the first choice there is wrong. Okay. Now, for the permanent dipole interaction, also it's wrong because it's non-polar and there is no hydrogen bond, so that's correct. There is no hydrogen bond. For CH4, it has London force since it has electrons, and you know the London force is related with the electrons. And here we have permanent dipole interaction. It does not exist because it's non-polar, so that's correct. And hydrogen bond does not exist. For ammonia, we have London force. Permanent dipole does not exist. That's wrong because it's a polar molecule and it includes hydrogen bond, so that's wrong answer. You will see London force exists in the hydrogen sulfide and permanent dipole is correct, and there is no hydrogen bond because the hydrogen is not bonded to one of the most electronegative elements, which is nitrogen or oxygen or fluorine. So the most correct answer is D. Now, for next question, which of these isoelectronic, the isoelectronic means that they have the same number of electrons. So isoelectronic compounds would be expected to have the highest boiling temperature. You will see this includes the hydrogen bond, and it is the longest chain at the same time. And the second one is 2-methylpropan-1-ol. It has a hydrogen bond. Also, this one has a hydrogen bond, but those are branched. Okay, and they have hydrogen bond. But the last one, there is no hydrogen bond, but it has London force only, the most common. All the others, they have also London force beside the hydrogen bond. So you will see that the first one has the hydrogen bond and it is the longest chain, which means that it is the strongest London dispersion force. So the correct answer is A. Now, for next one, what is the value of N in the half equation shown? Okay, this is kind of balancing equations. So you will see that we have two oxygen and two oxygen, they are 4 oxygen in the reactants part. So you shall multiply this by 4, and to balance the charge is 4 electrons. So the correct answer is 4. For question 7, which equation shows a disproportionation reaction? The disproportionation reaction is that reaction where the same element was oxidized and reduced at the same time in the same chemical reaction. For the first reaction, copper is 0 and it's positive 2 there, and the nitrogen is positive 5 and nitrogen there is positive 4. So you can see that 2 elements was changed their oxidation and oxidation states. So copper and nitrogen, they both changed their oxidation states. So it is not a disproportionation reaction. Iodine and oxygen in the second equation was changed. That's why it is not disproportionation reaction. Here, the same element was changed its oxidation state, but in part C, the reverse reaction is the disproportionation reaction, so that's not the answer. Here you will find that because the total charge is -2 equals 2s, for example, plus 3 times -2. So you will find that the oxidation state of sulfur there is +2. It is changed to +4, and it is changed to 0. So you can see it is reduced and it is oxidized at the same time. So here the same element in the reactant side was oxidized in the products and reduced also in the product. So the disproportionation reaction is D. Now, when sodium bromide reacts with the concentrated sulfuric acid, sodium hydrogen sulfate is always forms. What other products are formed in this reaction? Okay, sodium bromide, hydrogen bromide was formed, but it is further oxidized by concentrated sulfuric acid. So hydrogen bromide and bromine was also produced. Bromines and hydrogen bromide and sulfur dioxide also was produced, since that's the answer. But the hydrogen and sulfur, it's produced in the case of iodine, not in the case of the bromide. In the case of a chloride, it's only what's known as the sulfide. It's the hydrogen sulfide or sulfur can be produced. Okay, now we can go further for this paper. We have which property decreases as group 2 descended. Descended means going down the group. Now, the atomic radius, it increases down the group since we have more shells, and reactivity of elements, it increases because the electron is further from the nucleus, and it will cause what? It will cause the element to form positive charge in more, or it is easier to lose the electrons. The solubility of sulfates decreases because, you know, as you go down the group, you shall remember the trends of the sulfate solubility, and you will see that the thermal stability of nitrate, it increases because going down the group, the reactivity of the metal increases, so it's more stable in its compound. So the correct answer is C. Now, for next question, you have in a neutralization reaction 20 cubic centimeter, that's the volume of 0.5 mole cubic decimeter. Nitric acid reacts with 10 cubic centimeter of 1 mole cubic decimeter aqueous sodium hydroxide. That's the neutralization equation which is given in the question. What is the concentration in mole per cubic decimeter for the sodium nitrate that's produced? First of all, you shall find the number of moles for the reactants. Here you can consider that you shall find the limiting reagent. But if you find the number of moles of nitric acid, moles of nitric acid equals the volume over 1000 times 0.5. So on the calculator you will find it is 20 over 1000 equals times 0.5. This equals 0.01 moles. So we have 0.01 moles of nitric acid. And for sodium hydroxide moles, also we shall find the moles, which is 10 over 1000 times 1 molar. So also it is 0.01 mole. So both they are equal. Since the molar ratio is 1 to 1, also we have 0.01 moles of this, but the total volume is 30. So you divide the 0.1 over 0.033. This will give you 0.333 watt mole per cubic decimeter. That's the answer. So you divide 0.01 mole over the total volume, which is 30 times 10 to the power negative 3 watt cubic decimeter. That gives you this answer. Excellent. Good job. Now, the equation for the reaction of sulfur dioxide with oxygen is shown. Here we have sulfur dioxide, oxygen to give the sulfur trioxide. And the delta H of the reaction is negative 192 kilojoules per mole. What is the effect of decrease in the temperature? First, okay, you can see that he's asking about the decrease in the temperature. So that's what is needed. Wait, we select the thickness. Okay, now can be used. So he's asking you about the decrease in the temperature. As you can see, the decrease in the temperature, the rate increase. So in both choices where the rate increase is correct. But what about the yield? You know the reaction is an exothermic reaction. So increasing the temperature in an exothermic reaction will causes the shifting to the left. But here we have a decrease in the temperature, so the reaction goes to the right, so the yield will increase because the temperature was decreased. So the correct answer is B. Now, for next one, what is the effect of an increase in the pressure? Okay, first the rate increase, rate decrease. So you will see the effect of the pressure is increasing in the rate. Okay, هلا, and next he's asking you if the yield was decreased or increased. So if you increase the pressure, this will shift the equilibrium to the lower number of gas moles, which is the right side there, because here we have 2 and 1, 3 moles, but there we have 2 moles, so the reaction goes to the lower number of gas moles, so the rate increases, and also the yield was increased. So also here we have B, since the collagens was increased. Now, next question, a mixture of 1 cubic centimeter of 0.2 mole cubic decimeter potassium chromate and 5 cubic centimeter of 1 mole cubic decimeter sulfuric acid forms. He gave you what? The concentration and the volume of each one. What would be the effect, if any, on the color of the solution? 5 cubic centimeter and 1 molar concentration of sodium hydroxide. Sodium hydroxide there will react with the hydrogen, and this will decreases the amount of hydrogen ion. So this shifts the equilibrium to the left side, so the mixture becomes more yellow, not more orange, not visible, and that's it. For next question, the tertiary alcohols are used in the manufacture of petrol additives. Which of these is tertiary alcohol? Okay, here we shall draw the structure of each one. Look, if you did that, for the first one, it is 1-methyl cyclopentanol. So that's the structure. Sorry. The structure is pentanol, not hexanol. It is cyclopentanol. Okay, that's ON. But remember that here you have what? Methyl group. So it will be like that. For this carbon, it is attached with carbon there, okay, and here we have carbon, so it is tertiary alcohol. All the others, the second one is 2-methyl cyclopentanol, so 2-methyl, it will be like that. That's OH, now that's the methyl, so this is secondary. And 2-methyl-butan 1-ol, it's not, it is primary. This is primary, this is secondary, and this one is also secondary, the first one, which is the tertiary alcohol. Now, for next question, which reagents reacts with tertiary alcohol? Tertiary alcohol is not oxidized, so it will be the acidified aqueous potassium dichromate, it is not working with the tertiary alcohol, okay, because it is not working with the tertiary alcohol because it is not oxidized. Bromine water does not, this alcohol will not contain the double bond. That's reaction for the carbon-carbon double bond. Phosphorus 5 chloride or PCl5, it is used for all types of alcohols. That's why it's a correct answer. Sodium carbonate solution, it reacts with an acid, not with an alcohol. Here, the infrared spectra for the organic compound is used to identify the organic compound when propane 2-ol is refluxed with excess acidified potassium dichromate. The products will show the peak due to what? Here, you shall return back to the periodic table, to the data booklet. Okay, so the data booklet will tell you that the product is what? It is ketone because it's secondary alcohol, okay? And since it is a secondary alcohol, you will find the C double bond O stretching in the ketones, and this is present for D, which is this value. For the next one, the next question or the next part, when propane 1-ol is heated with acidified potassium dichromate, the product that is distilled off as is formed, it's a primary alcohol there, so the products will be what? Will be aldehyde, okay? It will be the product of this because it is distilled. And you see it is heated with acidified potassium dichromate, and it will be the aldehyde one, which is this one C double bond O. It is not the OH stretching, but that's present for the carboxylic acid. So the correct answer also is B. If you return back to the data booklet, you will find it is between 1720 and 1740 centimeter -1. Now, the next question is 15. Separate solutions of chloropropane and 1-bromopropane in ethanol are warmed with aqueous silver nitrate. That's the test of the halide ion. Why does the formation of a precipitate takes longer with 1-chloropropane? Okay, the first choice is 1-chloropropane is less soluble than 1-bromopropane. Now they have the same solubility, or it's not correct. The CCl bond is stronger than the CBr bond. Yeah, that's of course the reason, because the CCl bond has lower radius of chlorine atom compared to the iodide or a bromide, and this will give you a stronger bond. Now for CCl bond, it's more polar, but it's more polar, and that's not the reason we consider it's the case. Silver chloride is more soluble than silver bromide. No, that's not the reason. So the correct answer is related with the bond strength and why it takes more energy to break the stronger bond. A sample of propane 1,2-diol with a mass of 1.52 grams reacts completely with excess phosphorus chloride. What is the maximum mass in grams of the organic product. Okay, here what we have, what is done is the displacement of the propane diol. You will see that's the structure of propane diol. What's the structure of propane diol? It's 1, 2, 3, and here we have OH group, and here we have OH group. Since they are present on 1 and 2, they are displaced with what? With Cl groups with phosphorus 5 chloride, and the structure which is formed is something like that. And you are talking about hydrogen. It's 1,2-dichloropropane. Okay. Now he's asking you what's the maximum mass in grams of the organic product. Let us calculate the molar mass of the first one, which is 3 times 12 for all carbons. And you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, wait, 3 times 12 plus 8 hydrogens plus 2 times 16. So this equals 76. Now you can find the number of moles by dividing 152 over 76 of the diol. Okay, 1.52 over 76 of the diol. So this equals 0.02 moles, which is the same as the number of moles of the dichloro product. Let us calculate the molar mass of this. It's 3 times 12 plus 2, 3, and plus 6 hydrogens plus 71, which is 113 times 0.02. So this will give us 2.26 grams of this. So if you multiply the 0.02 times its molar mass, you will find the answer. Now, the next question is, which is the last question in part A or section A, which compounds reacts with ammonia to form CH3, CHNH2, CH3. It will be 2-chloropropane, since it is a substitution, nucleophilic substitution reaction, and since the ammonia or the amino group comes on the second carbon, so it will be 2-chloro. This will not react. This will not react with ammonia, and this will produce primary amine if it is reacted. As you can see, we analyzed each question. You shall return back to what you know about the theory of everything, every reaction, every energetics, organic chemistry, halogen alkanes reaction. That's what is included in this section. We will continue within more videos about the next part of this paper. Thank you for good listening.